Hello everyone, in this video we are going to learn how to draw the orthographic projection for the given three-dimensional component by the first angle projection method. So over the screen you will see one object is shown to which we have to draw the front view, top view and side view projection. Now to have the understanding for the completion of front view, top and side view, we have to understand the given direction for the observer. So in this case, this will be the direction for the observer. So observer is going to observe in this direction, and while looking in that direction he has to complete the front view projection, and while looking from the top end he has to complete the top view projection, and the remaining side for the observer is to have the observation from the left hand side. So in that case we are going to complete the left hand side view projection. So in first angle projection method, we have to complete the front view above the XY line, top view below the front view projection, and the left hand side view projection we are getting. Now let's start for the actual construction for this given component. So I have drawn one rectangle in which we are going to complete the front view, top and side view projection. Now to have the partition for all these three views, I have divided this rectangle by drawing the vertical line and the horizontal line in four parts like this. So in this rectangle we are going to complete the front view projection. Below this we are going to draw the top view projection, and to the right side of front view we are going to complete the left hand side view projection. Now to have these three rectangles, first of all we need to measure the dimensions for this given object. So in this object we have the total length is equals to 145, so that I have written over here, length is equals to 145, and height we are getting like this. So this base rectangle height we have 20 mm. Again from this top surface till this line we have 15 mm height. Again from this surface to this surface they have given 30 mm. Again from this surface to this line they have given 15 mm distance. So if we just sum all these distances, 20 plus 15 plus 30 plus 15, and in addition to that we have to add this height of this conical section 40 mm. So the total height we are getting 120 mm, and if you just observe the left hand side view over here, total width they have given 90 mm. So we have to draw the three rectangles for the front view, top view and left hand side view projections by considering the length and height for the front view, again top view by considering the length and width value, and the left hand side view projection by having width and height value. So all these three dimensions we are going to use to have these three rectangles, and that I have represented over here like this. So this rectangle will represent the front view projection, this rectangle will represent top view projection, and this rectangle will be for the left hand side view projections. Now if I just zoom this given object and consider the given direction for the observer, so while looking in that direction the observer is able to observe this base rectangle portion, and on top of that he is able to observe this C type portion, and along with that we will have this triangular surface, and on top of this C portion we are getting this conical surface. So the same I have represented over here for the better understanding which portion will be visible for the front view. So while looking in this direction the observer is able to observe this base rectangle, again this C type portion, this triangular surface, as well as this much portion of this conical surface. So this blue highlighted color is nothing but the portion visible for the observer while looking in that direction. Now we will complete the front view projection for the same. So we need to draw the base rectangle by the given dimensions, length is equals to 140 mm and height is equals to 20 mm. Again on top of that we need to draw this C type portion. To that we have this length 20 mm, this height they have given 15 mm, again this base height distance they have given 50 mm, and in between distance they have given 30 mm. And with respect to this vertical line we can imagine this triangular surface, and that distance they have given from this corner till this center point 35 mm, and if we just observe the portion behind this from this line till this center point they have given 20 mm distance. So we can have the total length calculation from this corner point to this corner point as 35 plus 20, so that will become 55 mm, and the total height we have 15 plus 30 plus 15, 60 mm. So we will start for the front view projection, so that we will have a clear cut idea how we are going to complete the front view projection for this given component. So you have to think about this much surface for the front view representation. So we are starting with this base rectangle, to which we have this length is equals to 145 mm and height is equals to 20 mm. So I have created the two layers. The one is for the object representation and another is for the projection lines. Okay, so I will change this layer to the object, going with this line command. Now I will start with this corner point for the front view, and from that you have to take height is equals to 20 mm. Press enter button. Just turn on this ortho mode command so that we can have the exact horizontal line, and we have the total length is equals to 145 mm. Again this height 20 mm, and just connect to the starting portion. So we are done with this base rectangle that is visible for the observer while looking in that direction. Now the next point is we have to represent this portion. Okay, and that we have 55 mm from this corner point till this point. So we can draw a line from this corner having length is equals to 55 mm, and from that we can take height is equals to 60 mm. So let's start with this projection. Again select the line command. You can select this corner point which will represent this corner point. This corner point and this corner point are in line with each other. So while looking in this direction, you will represent both the corner points as a single point over here in a front view. So from that we can take length is equals to 55. Again height is equals to 60. Again we need to draw the horizontal line. So that portion we need to measure over here in this diagram. So I am done with this corner point. Okay, and from that I have taken the length is equals to 55 mm, 35 plus this 20 mm distance. Again this corner point and this corner point are in line with each other while looking in this direction. So I can directly extend this vertical line for the height is equals to 60. Now we need to calculate this much distance. So if you just observe the distance from this corner point till this center line, they have given 50 mm distance. Now we need to add the radial value for this base conical surface, and this radius value we will get from this width value. So from this corner to this corner they have given 60 mm distance, which means we have the diameter for this base circle 60 mm. So radius will be the 30 mm. So we can have this total distance from this corner point to this center line 50, and from this center line to this end point 30 mm. So the total distance will be the 80 mm distance. So we will draw this horizontal line over here for the length is equals to 80 mm like this, and again from that we need to draw the vertical line from this point to this point, and to that they have given height is equals to 15 mm in a downward direction. Again from that we need to draw this horizontal line, and we have to keep this 20 mm distance so that we will reach to this point, and again from that we need to draw a downward line of 30 mm so that we can have this corner point. Again just draw the horizontal line for the remaining length and just connect to this baseline, so that we will have this C type portion in a front view projection. So from this corner point we need to draw 15 mm. Again horizontal distance we have taken this total length is equals to 80, and from that we have to subtract this 20 mm distance. So we'll enter 60 mm distance over here. Again in a downward direction 30 mm distance. Again horizontally 60 mm distance, and just connect it to the baseline and press enter button. So this C type portion will represent this portion that the observer is going to observe while looking in this direction. Now to have this inclined line, we can imagine that portion over here. So this vertical line is nothing but this vertical line that we have represented over here, because while looking in that direction both these lines are in line with each other. So we can represent a single vertical line for these two lines over here, and that we have represented over here already. Similarly this baseline is in line with this line. Okay, so we have that portion somewhat over here. So I will go with the line command and directly connect this corner point to this corner point so that we can have that triangular surface over here. So just go with the line command, turn off this ortho mode command because we are drawing an inclined line like this. Now if I just press enter button, you can see I am done with this triangular surface as well, which is nothing but the representation for this rib section while looking in that direction. Now the remaining portion is we need to draw this conical surface in a front view projection. Now to have that representation, first of all we need to identify the center point for this conical section. So if I just zoom this portion, you are able to see that from this corner point till this center line they have given this 50 mm distance. So the same center point we can have over this line, and from that point we can imagine this given height 40 mm. So I am going to draw the distance from this corner point to this point as 50 mm. Again from this point I am going to draw this height is equals to 40 mm, and just to have this horizontal representation we need to imagine the diameter for this outer circle. So what is that? 40 mm. So this distance is nothing but the 20 mm radial value. So I can draw a line from this base corner point, okay, from this corner point till over here, which is going to represent the center line at a distance of 50 mm, and from that I am going to take height is equals to 40 mm and again horizontal 20 mm radial value, and that corner point I am going to connect. So this will be the outline for the front view projection. Now we will draw the top view projection. So while looking from the top end, the observer is able to observe this orange color highlighted portion. So when looking from the top view, he is able to observe these two concentric circles along with the base circle for that conical surface, and this orange shade for the baseline along with this inclined rib section and this base rectangular portion. So we will start with this base rectangular portion first. So I will go with the object layer, continuous line type. So just draw one rectangle by selecting all those corner points, because already we have taken this rectangle for the given and length and width value. So just complete that rectangle. This will represent the base rectangle. So though they have given these fillet surfaces for all the corner points, initially we are going to draw all these corner points as it is. Later on we will provide the fillet at all those corner points. Now when the observer is going to observe from the top end, he is going to observe this inner circle, again this outer circle and this base circle. So total 3 concentric circle he will observe while looking from the top end. Now to have the representation for these 2 concentric circles at the top surface and the 1 circle at the base surface, we need to locate this center point, and that we can observe over here. So this center point we need to locate in the top view rectangle, and that we will have over this center line. So we need to draw that center line, and that is going to pass exactly at the midpoint of this total width is equals to 90 mm. So we have this 90 mm width over here. Okay, so just go with the projection layer, go with the line command. Here you will find the midpoint for that 90 mm width. Just draw one center line like this. Similarly, we need to transfer the projection line from the front view, because this is going to represent the center line or the axis in the front view portion, so that we can extend in a vertical downward direction. So at the intersection we are getting this center point. Okay, so this center point we can imagine over here. Now with respect to that center point, we can draw the 2 concentric circles at the top surface, for which we have this inner circle diameter 20 mm and outer circle diameter is equals to 40 mm. So just change the layer to the object, go with the circle and radius command, this as a center point, inter radius is equals to 10 for the inner circle diameter. Again go with the same command, select this as a circle center and radius is equals to 20. Again go with the same command, select this as a center point and radius is equals to 30 mm. So we are done with these 3 concentric circles. Okay, this one as well as the circle for the base surface. Now if you just observe carefully over here, with respect to this base circle, we have the tangent line on either side, okay, and that is up to this corner point. So this corner point already we have represented in a front view, okay. So this corner point already we have in a front view projection over here. So the same corner point we can project in a top view, and to that we can draw the tangential line. So just select the layer to the projection, go with the line command, and the same corner point we can transfer in a top view projection, okay. So just move your cursor over this corner point, don't click over there, just move your cursor and drag it in a downward direction, so that you will have the green guideline. By means of that we can refer the starting point over here, okay. So this will be the starting point for that point. Turn on this ortho mode command and just click over here. So we will have the general guideline that this tangential line is up to this corner point, okay. So that corner point we have transferred in a top view projection. Now just change the layer to the object, go with the line command, select this outer circumferential point, and from that you have to draw the horizontal line till this line. Again move it in a vertical upward direction, but we don't know at what point we have to stop. So to have that point, you have to move your cursor over this point, don't click over there, just move your cursor over there. Again you will have the green guideline, okay, and just move that cursor to the left side and you will get that intersection point over there. So just click on that and again move it to the right side. So by this way we are done with this outline, okay. Now this portion that I have drawn right now is nothing but this orange portion we have over there, okay. Now the remaining thing is just you have to represent this inclined surface. So that we will do in a top view representation with respect to this center line. So that rib section we are going to represent from this corner point, okay, and exactly with respect to this given center line we are going to represent on the either side. So the total rib width they have given 10 mm, so we can have that rib line with respect to this center line. So just go with the object layer, go with the line command. From this point we have to take vertical distance 5 mm. Again we have to draw the horizontal line. So to have that exact horizontal line, turn on this ortho mode command, just click over here. Again from that point enter 10 mm and just move horizontally to get this point and just end over there. So this rectangle is nothing but this portion, okay, this inclined portion in a top view portion, okay. So this is nothing but the rectangle for the rib that we have over there. Now the next important thing is we have to draw these two circles which are visible to the observer while looking from the top end. Now first of all we need to identify the distances for that center points, okay. So this distance they have given 20 mm and this distance they have given 20 mm. So from this corner point we can imagine this 20 mm distance as well as this 20 mm distance. Again from this corner point we need to imagine this 20 mm distance and this 20 mm distance. So the same we are going to represent over here. So let me go with the projection layer once again, go with the line command. So from this corner point I am going to draw a vertical line for the 20 mm and horizontal line for the 20 mm and just press enter button. So this end point is nothing but the center point for that circle. Similarly I am going with the line command once again, select this corner point, enter 20 mm distance in a vertical downward direction and horizontally 20 mm. So again this end point is nothing but the center point for that circle. Now what is the diameter for that two circles? Here they have given diameter is equals to 16 mm. So just go with the circle and radius, select this as a center point and here you have to enter radius is equals to 8, okay. So just select that once again and change it to the object layer so that we can have that object line, okay. So go with the circle command once again, select this center point and enter radius is equals to 10 mm. Similarly if you just observe this curvature, okay, at all the four corner points, in that case you have to imagine this as a center point and this as a radius value. So the total distance they have given 20 mm. So we need to draw a circle having radius equals to 20 mm to get that fillets on every corner point. So just go with the circle command in a simpler way, select this as a center point and this as a radius. Again select the circle command, select this center point, this as a radius value. Okay, now go with the trim command, press enter button and just trim out the portion that we don't want to represent in the top view projection like this. Again we can trim this surface as well. Again trim this surface. So overall we are getting this two fillet curves in a top view. Okay, the same we are going to represent at this point as well. So if you just observe the total length we have, that is nothing but the 145 mm. Okay, so to get the remaining fillet curves on the other end, we need to find the midpoint for this total rectangle, and over there we are going to draw one vertical line so that we can have the mirror image for these two fillet curves. So just go with the projection layer, go with the line command. So somewhat over here we are getting the midpoint, so this will be the starting point and this is nothing but the midpoint for that total rectangle. So you can imagine the vertical line over there. Select the mirror command, select these two fillet curves, press enter button and just use this vertical line as an axis for the mirror and press enter button. Now go with the trim command once again, press enter button and just trim out these extra lines that we have on either side of this rectangle like this. So we are done with the outline for the top view. Okay, now you can imagine these two concentric circles, okay, that I have shown over here, the inner circle and the outer circle. The base conical circle I have shown over here, and this portion is nothing but this line, okay, that the observer is going to observe while looking from the top end, and this inclined surface is nothing but this rectangular surface. Okay, and these are the two circles visible while looking from the top end as it is, and these are the fillet curves at all the four corner points. So this is all about the overview of the top view. Okay, again I have not shown the hidden surfaces in a top view as well, only the highlighted points I am going to represent it over here, which are the clearly visible for the observer while looking from the top end. Now we will complete the side view projection in a similar way. So while looking from the left hand side, the observer is able to observe the surfaces highlighted by the green color. So while looking in that direction, he is able to observe this portion. Okay, again he is able to observe this inclined surface, again these two rectangles on either side, and this much portion of that conical surface. So though we have the curved surface in a front view and side view, okay, if you just imagine the direction for the observer up to this vertical line, he is going to observe that curved surface. So though we have the curved surface over here, okay, he is going to observe the vertical line on either side. So we have a rectangle in a side view, and to that we have the height is equals to 20 mm, and the same we have taken in a front view as well. So the same height we can carry in a side view projection. So just go with the projection line, select line command, draw the horizontal projection line like this. So just change the layer to the object, go with the line command once again. Now this will be the starting point, this will be the 20 mm height, again this much will be the width value, again this corner point and this corner point. So this rectangle that I have drawn right now is nothing but this much portion at the base. Okay, now we will draw the center line for the side view. So if you just observe this given object, so this line is nothing but the center line for the side view projection. Okay, so the total width we have 90 mm, so we need to draw the center line at a distance of 45 mm, so that we will have from the top view. Okay, so just change the layer to the projection, go with the line command. Now already I have drawn the 45-degree inclined line over here, so on that line I am going to transfer this distance directly like this, which is going to represent this total width from this point to this point. In a similar way I am going to transfer the center line from the top view by drawing the horizontal lines like this. So just zoom that portion, again press enter button, and from the intersection point you have to draw the vertical line which is going to represent the center point for the side view. Now this will help us to draw this rib section. Okay, so this rib section we are going to represent with respect to this center line, and to that they have given width is equals to 10 mm. So on either side we have to draw 5 mm 5 mm line. And what is the height for that? If you just observe carefully, this will be the starting point and this will be the end point. And though we have the inclined surface, the total height we can imagine from this point to this point, because these 2 points are in line with each other. So the same point we can represent for these two, and we can take the total height is equals to 60 mm, and the same height already we have in a front view projection over here. Okay, so again I am going to draw a line for this corner point, okay, in a side view projection like this. Now I am going to change to the object layer, go with the line command, select this as a starting point, to the right side 5 mm distance, again just zoom out vertically 60 mm distance, again horizontally 10 mm distance, and in a downward direction again 60 mm, and just connect it to the center point. So we are done with this inclined surface. Okay, so though it is inclined, we are going to represent it as a rectangle like this. Now once we're done with this rectangular rib section, the next thing is we have to draw these vertical rectangles on either side of this inclined surface. So to have that representation, go with the projection layer, select the line command, and that projections we are going to transfer from the top view. Okay, so these are the corner points we need to transfer in a side view projection from the top view. So just transfer that point over this 45-degree inclined line, press enter button to activate the line command once again, and from that corner point we need to transfer it vertically. So till this height we have that width over there. So again go with the line command, select the other corner point, and the same corner point we are going to extend over this 45-degree inclined line and click over there. Again go with the line command, transfer it in a vertical upward direction. Now you can imagine this much portion will represent this rectangle, this much portion will represent this rectangle to the right side. So just change the layer to the object, select this corner point, this corner point, this corner point, press enter button from this point to this point. Okay, select this corner point, this corner point, and again this corner point. So we are done with these two lines. Now you can imagine we are done with these rectangles on either side. Now to have the representation for this conical surface that will be visible while looking from the left hand side view, we just need to understand these extreme 2 points we need to transfer in a vertical upward direction, so that we can connect this base corner point in an inclined manner to this top circle corner point, and that we are getting from the top view. So this middle circle will represent this upper circle. Okay, so we need to draw the projection line from the top view by selecting the projection layer. So these two corner points we are going to transfer over this 45-degree line like this. Again press enter button, select this intersection point, and just transfer it in a vertical upward direction. In a similar way, go with the line command once again, select this middle circle, transfer it over this 45-degree line, again press enter button, and from the intersection again you have to draw the vertical line like this. So just connect all those points by selecting the object layer. So this corner point is nothing but the base corner point that we have over here. Okay, and this corner point will represent this base corner point that we have over here. So these two points are in line with each other, so we can select the corner point directly and just connect it to this point like this. Just connect it over there, and again draw this line and press enter button. Now select this rectangle separately. So we are done with this upper conical section as well. Now to represent the hidden surfaces in all the three views, we need to understand one rule. Suppose this will be the direction for the observer for the front view. Okay, so while looking in that direction, the observer is unable to observe these two circles present over this horizontal rectangle. Along with that, he is unable to observe this inner circle present inside this conical surface. Again this circle as well, that is present over this horizontal surface. Now the one thumb rule is to have the better understanding for the hidden surfaces. We need to transfer all these hidden surface outlines in the direction of the observer, which means that suppose this will be the center line for that circle, okay, and that we have in a vertical manner for this much height. So this center point we can transfer in the direction of the observer. So we can have that center point over here, and that we can imagine like this, okay. Similarly, we need to imagine the either side circumferential points, and that again we need to transfer in the direction of the observer. So on the either side we are getting these two lines, okay, on the other side of the center line, and that we are going to represent in front view over here. So already we have this center line, okay. On either side we are going to represent these two circumferential points, and that we are going to represent for this much height, okay, from this surface to this surface, again from this surface to this surface. So if we just represent in a front view by selecting the dash line, go with the line command, we need to transfer this inner circle point in a vertical upward direction. So just move your cursor over this inside circle, don't click over there, just move your cursor on that circumferential point and just move it in a vertical upward direction. So we will have a green guideline, okay, from that circumferential point, and just click where we can represent that center line like this. So for this much height we need to draw the center line on either side. Similarly, move your cursor at this point by selecting the line command, again drag it in a vertical upward direction. So from this point to this point we need to represent this dash line like this. Similarly, just go with the mirror command, select this line, press enter button, select this center line. We can have the hidden surface representation for this inner circle like this, okay. Now select this line separately and change it to the line type as a center line, okay. Select this point and just lengthen it for this much height and press escape button. Again just zoom it, select that line separately, right click on that rectangular block, you will find another window over the screen, and there you will find line type scale. So just change it to the 2, or you can change it to the 3, so that the center line is visible properly, and you can change the color type, okay, to the red, and just press escape button. Now you can imagine we have that center line in the front view, okay. So this center line is nothing but the center line for these two circles in a vertical manner. Now similarly we can represent these two circles present over the base rectangle, okay. Now to have that representation, go with the projection layer, select the line type to the continuous, go with the line command, select this center point, draw it in a vertical upward direction, again go with the line command, select this circumferential point, draw in a vertical upward direction like this. Again just go with the match property, select this as a source object and this as a center line. So this will represent the center line. Go with the dash line and the object layer, select the line command, from this point to this point you have to represent the hidden surfaces, okay. Again go with the mirror command, select this as a source, press enter button, and this as a mirror axis, so that we can have the circle representation with respect to the center line on either side. Now to change the line spacing for the dash line as well, you have to select that line separately, just right click once, go with the property, and here you have to enter the line space distance is equals to 0.5, so that we can have the proper representation of that hidden surface as relative to this center line. So just go with the match property, select this as a source object and just click over the hidden surfaces that we have represented in a front view like this. So we are done with the front view representation for the hidden surfaces. Now if we just talk about the top view surface, while looking from the top end, only these two corner points are invisible. Okay, so if we just recall our thumb rule, we need to transfer these two corner points in the direction of the observer. Now in that case, the observer is looking from the top end, so we need to transfer these two corner points in a vertical upward direction. So we will have that corner point somewhat over here, and from that point we need to draw the horizontal line along in the direction of the width value. Okay, so the total width we have 60 mm. So already we have this line, okay, in a top view over here. So this number will be this line. So we need to transfer these two corner points in a vertical downward direction, and from that point we need to represent this hidden surface. So just go with the object layer and dash line, go with the line command, move your cursor to these corner points, don't click over there, so just drag your cursor in a downward direction so that we can have the green guideline. Okay, now this is the starting point for that. Only a single line will be there in a top view as a hidden surface for these two corner points. All other portion is visible for the observer while looking in that direction. Now we will discuss the side view representation, so which are the hidden surfaces. So if you just imagine, this will be the direction for the observer for the side view representation. These two base circles are hidden while looking in that direction. Again, these two corners are hidden surfaces, okay, and this inner circle is again hidden surface for the side view representation. Now to have those representations, first of all we will represent these two corner points, because already we have these 2 points in a front view over here. Okay, so directly we can transfer these corner points horizontally for this much width, and that width already we have taken over here. So just go with the object layer and the hidden line type, select the line command, move your cursor over here, okay, and just drag horizontally so that we can have the horizontal guideline, and from this point to this point we need to represent that hidden surface. Now this line that I have drawn right now is nothing but this corner point, okay, and that we are having for the throughout width is equals to 60 mm. So again you have to imagine that this corner point we are going to project in the direction of the observer, and that we will have somewhat over here, and from that point we are going to represent horizontally in the direction of the width. So here we can imagine that hidden surface. Okay, in a similar way we are going to represent this corner point as well in the direction of the observer, so that we will get somewhat over here, and again from that point we are going to represent for the total width is equals to 60 mm. And the same we can have by means of projecting this corner point in a horizontal manner. So this will be the starting point and this will be the end point for the width is equals to 60 mm. So we are done with these two hidden surface lines, okay, for this corner and this corner. Now we will represent this inner circle, and already we know that inner circle is for this much height, okay, from the top surface to this surface, again from this surface to this surface. Now to have that representation we need to transfer this inner circle circumferential point over this 45 degree, and that again we are going to represent in a vertical upward direction. So just change layer type to the projection and line type to the continuous, go with the line command, select this inner circle circumferential point, project it over the 45 degree line. Let me press the escape button and draw it once again. Go with the projection layer, select this line, just zoom this portion, click once over there, again press enter button, and from this intersection you have to draw a vertical line like this. Now we can imagine the circle is present from this side to this side. So just go with the object layer, line type to the dash line, go with the line command, from this point to this point we need to represent like this. Again you can represent the same circle for this much height like this. Go with the mirror command, select these two lines separately, press enter button, and this as a axis. So on either side we are getting that inner circle. Okay, so this inner circle we are going to represent from this side to this side, again from this side to this side. Now the remaining task is we need to use the match property so that we can have the similar representation for the center line in a side view as well, like this. Similarly in a top view, so that we can easily identify which are the center lines we have used over here. Again, we need to draw a center line over here as well, because this is nothing but the center line in a top view as well. So just select this line, use the match property. Now it is very clear to imagine which are the center lines we have used to draw these projections. Again, go with the match property, select this as a source and these two lines as a destination. Okay, now the remaining thing is to represent these two base circles present over the base rectangular surface. Now to have that representation, again we need to go with the projection layer, continuous line type, go with the line command, select this center point, project horizontally over this 45-degree line. Again press enter button, and from the intersection you have to draw the vertical line like this. So this will be the center line. In a similar way, we are going to project the circumferential point for this top view circle as well. Draw the horizontal projection lines over the 45-degree line, and from the intersection again draw the vertical line like this. Now go with the object layer and the dash line, go with the line command. So this circumferential projection line we are going to use to have the representation like this. Similarly, go with the line command once again, and this we are going to represent as a center line, this line from this point to this point. Go with the match property, select this as a source, this as a destination, press enter button. Again go with the match property, this as a source, this as a destination. Again go with the mirror command, select this as a object and this as a mirror axis. So we are done with the one circle, okay, in a side view representation. Go with the mirror command once again, select these three lines separately, press enter button, and this as a mirror axis. So directly we are getting the other circle like this. So just select that line separately and delete it, because we have drawn it repeatedly, that's why that is invisible over there. So just go with the continuous line type and just connect these 2 points. So we are done with the front view, top and side view representation along with the hidden surfaces. So this is your final diagram. Just we need to give the dimensions one by one and just complete these projections. Thank you.